Have you ever stopped to wonder how a thought, an idea written down in a programming language, actually becomes a real action on your screen? So today, we're going to dive into a hidden but absolutely essential part of that process. And we're going to look at it not as some dry technical problem, but more like a story about a master translator.
It really is a fascinating question when you think about it. You know, a developer types out x equals y plus z, just a simple line of text. And somehow, the computer understands this not as text, but as a command to take two numbers, add them up, and store the result somewhere. So what's the magic trick happening in between? Well, that trick, it's all about translation.
At the very heart of this whole process is something called the compiler. Its job is to take the language we humans write, the source code, and translate it into the only language the machine actually understands, the target code. And within this master translator, there's a final crucial specialist who does the last bit of work. And you can see that whole journey laid out right here. The code generator takes the kind of abstract blueprint of our code and performs the final, really delicate act of translation. It's the bridge that connects pure logic to the physical actions happening on the machine. And look, this isn't just some abstract academic thing. The quality of this final translation affects you every single day. When this translation is done well, your app feels snappy and fluid. But when it's done poorly, everything feels sluggish and slow. So yeah, the choices this final translator makes are incredibly important.
Okay, so to really get how the code generator works, we have to ask three fundamental questions it needs to answer. And the first one is all about its input. What exactly is it being asked to translate in the first place?
Now you might think it just looks directly at the Python or C++ code that was originally written, but it doesn't. By the time our master translator gets involved, the original language has already been, kind of chewed up and simplified into something much more fundamental.
Instead, it works from this, a simplified representation called intermediate code. This example here shows what's known as three-address code. It breaks down complex ideas into these super simple, unambiguous steps. T equals A plus 2. Then A index equals T. It's like this pure distilled logic, a kind of universal blueprint that isn't tied to any specific computer just yet. This is the raw material for our translation.
All right, so once the generator knows what it's translating, it has to ask that second key question. Who's the audience here? Who am I translating this for?
The audience is the target machine, the specific processor in your phone or your laptop or some server somewhere. And the crucial thing is, not all processors speak the same language. They have different instruction sets, different rules, you could even say different dialects. The translation has to be tailored perfectly for the listener.
And this gives you a perfect little comparison of those differences. A RISC processor, for instance, likes lots of very simple, very fast instructions. A CISC processor might have fewer, but much more powerful and complex instructions. So the code generator can't just spit out some one-size-fits-all translation. Nope. It has to be a fluent speaker in the specific dialect of its target machine. Which, leads us right to our third and final question. The generator knows what to say and who to say it to. Now it has to figure out how to say it. Like, how should I phrase this translation for the best possible result?
Let's go back to our simple expression x equals y plus z. The generator has choices. Okay, so method A is pretty literal, almost a word-for-word translation. It loads y and z into separate little storage spaces on the processor called registers, adds them, and then stores the result. But check out method B. It's a little more clever, right? It loads y into a register, adds z directly to that, and then stores the result. It uses fewer steps and fewer resources. That choice, choosing method B, that's what makes a program feel fast and efficient.
So we've got these three big challenges: understanding the blueprint, speaking the machine's dialect, and choosing the right words. But kind of hanging over all of them is one single unbreakable rule. And here it is, straight from the authors of one of the most famous books on this topic: the number one priority is correctness. I mean, think about it. A super fast program that gives you the wrong answer, that's worse than useless. The translation must, above all else, preserve the original meaning of the code.
It's a really simple idea to hold on to. All the clever optimizations, all the elegant instruction choices, they all take a back seat. The generator's primary duty is to be a faithful translator. It has to get the meaning right every single time, across potentially millions of lines of code.
When you zoom out, you start to see these kinds of processes everywhere. An elegant, hidden world of translation that's happening constantly, just beneath the surface of the technology we all use.
It kind of makes you wonder, doesn't it? What other master translators are out there, just quietly and correctly shaping the digital world all around us?